Hello children, welcome to this video session. In this today's video session, we are going to learn Unit 7, Eat from your 9th standard science book. Come, let's get into this video session.
Hello children, today we are going to learn Unit 7, Eat. All substances in our surrounding are made up of molecules. These molecules are generally at motion and possess kinetic energy. At the same time, each molecule exerts a force of attraction on other molecules and so they possess potential energy. The sum of the kinetic and potential energy is called the internal energy of the molecules. This internal energy, when flows out, is called heat energy. This energy is more in hot substances and less in cold substances and flows from hot substances to cold substances. Let's see effects of heat. When a substance is heated, the following things can happen. Expansion. When heat is added to a substance, the molecules gain energy and vibrate and force other molecules apart. As a result, expansion takes place. You would have seen some space being left on railway tracks. It is because during summertime, more heat causes expansion in tracts. Expansion is greater for liquids than solids and it is maximum in gases. Next effects of heat is change in state. When you eat ice cubes, they become water and water on further heating changes into vapor. So, solid becomes liquid and liquid becomes gas when heat is added. The reverse takes place when heat is removed. This is what change in state. Next effects of heat is change in temperature. When heat energy is added to a substance, the kinetic energy of its particles increases and so the particles move at higher speed. This causes rise in temperature. When a substance is cooled, that is, when heat is removed, the molecules lose heat and its temperature falls. This is change in temperature. Now, chemical changes. Since heat is a form of energy, it plays a major role in chemical changes. In some cases, chemical reactions need heat to begin, and also heat determines the speed at which reactions occur. When we cook food, we light the wood and it catches fire, and the food particles become soft because of the heat energy. These are all the chemical changes taking place due to heat. Transfer of heat. Take a glass of water and put some ice cubes into it. Observe it for some time. What happens? The ice cubes melt and disappear. Why did it happen? It is because heat energy in the water is transferred to the ice. Heat does not stay where we put it. Hot things get colder and cold things get hotter. Heat is transferred from one place to another till their temperatures become equal. Heat transfer takes place when heat energy flows from an object with a higher temperature to an object with a lower temperature. Do you know when a dog keeps out its tongues and breathes hard, the moisture on the tongue turns into water and it evaporates. Since heat energy is needed to turn a liquid into gas, heat is removed from dog's tongue. This helps to cool the body of the dog. So, heat transfer takes place in three ways, that is, conduction, convection, radiation. Let's see one by one. Conduction. In solids, molecules are closely arranged so that they cannot move freely. When one end of the solid is heated, molecules at that end absorb heat energy and vibrate fast at their own positions. These molecules in turn collide with the neighboring molecules and make them vibrate faster, and so energy is transferred. This process continues till all the molecules receive the heat energy. So, conduction means it is the process of transfer of heat in solids from a region of higher temperature to the region of lower temperature without the actual movement of molecules is called conduction. Conduction in daily life. Metals are good conductors of heat. So, aluminum is used for making utensils to cook food quickly. Mercury is used in thermometers because it is a good conductor of heat. We wear woolen clothes in winter to keep ourselves warm. Air, which is a bad conductor, does not allow our body heat to escape. Next, convection. Drop a few crystals of potassium permanganate down to the bottom of the beaker containing water. When the beaker is heated just below the crystals by a small flame, purple streaks of water rise upwards and fan outwards. In this activity, water molecules at the bottom of the beaker receive heat energy and move upward and replace the molecules at the top. Same thing happens in air also. When air is heated, the air molecules gain heat energy, allowing them to move further apart. Warm air, being less dense than cold air, will rise. Cooler air moves down to replace the air that has risen. It heats up, rises, and it again replaced by cooler air, creating a circular flow. So, convection means is a flow of heat through a fluid from places of higher temperature to places of lower temperature by movement of the fluid itself. Convection in daily life. Hot air balloons. Air molecules at the bottom of the balloon get heated by a heat source and rise as the warm air rises. Cold air is pushed downward and it is also heated. When the hot air is trapped inside the balloon, it rises. This is the example of convection in daily life. Another example of convection in daily life, breezes. During daytime, the air in contact with the land becomes hot and rises. Now the cool air over the surface of the sea replaces it. It is called sea breeze. During night time, air above the sea is warmer. As the warmer air over the surface of the sea rises, cooler air above the land moves towards the sea. It is called land breeze. Radiation. Radiation is a method of heat transfer that does not require particles to carry the heat energy. In this method, heat is transferred in the form of waves from hot objects in all directions. Radiation can occur even in vacuum, whereas conduction and convection need matter to be present. Radiation consists of electromagnetic waves traveling at the speed of light. Thus, radiation is the flow of heat from one place to another by means of electromagnetic waves. Transfer of heat energy from the sun reaches us in the form of radiation. Radiation is emitted by all bodies above 0 Kelvin. Some objects absorb radiation and some other objects reflect them. While firing wood, we can observe all the three ways of heat transfer. Heat is one end of the wood will be transferred to other end due to conduction. The air near the wood will become warm and replace the air above. This is convection. Our hands will be warm because heat reaches us in the form of radiation. Radiation in daily life. White or light colored clothes are good reflectors of heat. They keep us cool during summer. Base of cooking utensils is blackened because black surface absorbs more heat from the surrounding. Surface of airplane is highly polished because it helps to reflect most of the heat radiation from the sun. Concept of temperature. Temperature is the degree of hotness or coldness of a body. Hotter the body, higher is its temperature. Unit of temperature is Kelvin. For day-to-day applications, Celsius, that is degrees Celsius, is used. Temperature is measured with a thermometer. There are three scales of temperature: Fahrenheit scale, Celsius or centigrade scale, Kelvin or absolute scale. In Fahrenheit scale, 32 degree Fahrenheit and 212 degree Fahrenheit are the freezing point and boiling point respectively. Interval has been divided into 180 parts. In Celsius scale, also called centigrade scale, 0 degrees Celsius and 100 degrees Celsius are the freezing point and boiling point respectively. Interval has been divided into 100 parts. The formula to convert a Celsius scale to Fahrenheit scale is F is equal to 9 by 5 into C plus 32. The formula for converting a Fahrenheit scale to Celsius scale is C is equal to 5 by 9 into F minus 32. Kelvin scale. Kelvin scale is known as the absolute scale. On the Kelvin scale, 0 Kelvin represents absolute zero, the temperature at which the molecules of a substance have their lowest possible energy. The solid, liquid, gaseous phases of water can coexist in equilibrium at 273.16 Kelvin. So Kelvin is defined as 1 by 273.16 of the triple point temperature. The formula for converting a Celsius scale to Kelvin scale is K is equal to C plus 273.15. Absolute zero. The temperature at which the pressure and volume of a gas theoretically reaches zero is called absolute zero. This is what given in this figure. For all gases, the pressure extrapolates to zero at the temperature minus 273.15 degrees Celsius. It is known as absolute zero or 0 Kelvin. Some baseline temperatures in the three temperature scales are shown in this figure. Boiling point of water in Kelvin scale is 373.15. in degrees Celsius 100 and degree Fahrenheit 212. Melting point of ice in Kelvin scale 273.15 and in degree Celsius 0, in degree Fahrenheit is 32. Absolute 0 in Kelvin scale is 0, in degree Celsius is minus 273, in degree Fahrenheit minus 460. Specific heat capacity. You might have felt that the land is cool in the morning and hot during daytime, but water in a lake will be almost at a particular temperature both in morning as well as in the afternoon. Both are subjected to same amount of heat energy from the sun, but they react differently. It is because both of them have different properties. In general, the amount of heat energy absorbed or lost by a body is determined by three factors. 1. Mass of the body. 2. Change in temperature of the body. 3. Nature of the material of the body. We can understand this from the following observations. Observation 1. Quantity of heat required to rise the temperature of 1 liter of water will be more than the heat required to rise the temperature of 500 ml of water. If Q is the quantity of heat absorbed and M is the mass of the body, then Q is directly proportional to the M, that is, quantity of heat is directly proportional to the mass of the body. Observation 2. Quantity of heat energy Q required to rise the temperature of 250 ml of water to 100 degrees Celsius is more than the heat energy required to rise the temperature to 50 degrees Celsius. Here, Q is directly proportional to the delta T, where delta T is the change in temperature of the body. Thus, heat lost or gained by a substance when its temperature changes by delta T is Q directly proportional to the M delta T. So Q is equal to M into C delta T. So when you remove the proportionality, you'll get Q is equal to M C delta T. Delta T is the change in temperature. From the above equations, the absolute temperature and energy of the system are proportional to each other. The proportionality constant is the specific heat capacity C of the following. Therefore, C is equal to Q by M delta T. Thus, specific heat capacity of a substance is defined as the amount of heat required to rise the temperature of 1 kilogram of substance by 1 degree Celsius or 1 Kelvin. Change of state. The process of changing of a substance from one physical state to another at a definite temperature is known as change of state. For example, water molecules are in liquid state at normal temperature. When water is heated to 100 degrees Celsius, it becomes steam, which is a gaseous state of matter. On reducing the temperature of the steam, it becomes water again. If we reduce the temperature further to 0 degrees Celsius, it becomes ice, which is a solid state of water. Ice on heating becomes water again. Thus, water changes its state when there is a change in temperature. There are different such processes in the change of state in matter. This figure shows that Change of state of matter. Melting to freezing. The process in which a solid is converted to liquid by absorbing heat is called melting or fusion. The process in which a liquid is converted to solid by releasing heat is called freezing. Boiling to condensation. The process in which a liquid is converted to vapor by absorbing heat is called boiling or vaporization. The process in which a vapor is converted to liquid by releasing heat is called condensation. Sublimation. The process in which a solid is converted to gaseous state is called sublimation. Latent heat. The word latent means hidden. So, latent heat means hidden heat or hidden energy. In order to understand latent heat, let us do the activity that is given here. Take some crushed ice cubes in a beaker and note down the temperature using thermometer. It will be 0 degrees Celsius. Now heat the ice in the beaker. You can observe that ice is melting to form water. Record the temperature at regular intervals and it will remain at 0 degrees Celsius until all ice is converted to liquid. Now heat the beaker again and record the temperature. You can notice that the temperature will rise up to 100 degrees Celsius and it will retain the same even after continuous heating until the whole mass of water in the beaker is vaporized. In the above activity, temperature is constant at 0 degrees Celsius until entire ice is converted into liquid and again constant at 100 degrees Celsius until all ice is converted into vapor. Why? It is because when a substance changes from one state to another, a considerable amount of heat energy is absorbed or liberated. This energy is called latent heat. Thus, latent heat is the amount of heat energy absorbed or released by a substance during a change in its physical states without any change in its temperature. Heat energy is absorbed by the solid during melting and an equal amount of heat energy is liberated by the liquid during freezing without any temperature change. It is called latent heat of fusion. In the same manner, heat energy is absorbed by a liquid during vaporization and an equal amount of heat energy is liberated by the vapor during condensation without any temperature changes. This is called latent heat of vaporization. Specific latent heat. Latent heat, when expressed per unit mass of a substance, is called specific latent heat. It is denoted by the symbol L if Q is the amount of heat energy absorbed or liberated by mass m of a substance during its change of phase at a constant temperature, then specific latent heat is given as L is equal to Q by M. Phases means solid, liquid and gases, that is three phase. Thus, specific latent heat is the amount of heat energy absorbed or liberated by unit mass of a substance during change of state without causing any change in temperature. So the SI unit of specific latent heat is joule per kilogram. Thank you, children.